Welcome back. We are looking at the solar system in this chapter, and we're going to finish the solar system looking at the very small objects left over. We've looked at the sun, we've looked at the planets. We're now going to look at the asteroids and the comets and some of the planetesimals, some of the small dwarf planets. Everyone knows Pluto used to be considered a planet. It's no longer, it was deplanetized. So we're going to look at these objects. Also, the two belts that exist in the solar system, the Asteroid Belt and the Kuiper Belt, and some really interesting things we'll find in this section. We'll first look at the asteroids. And asteroids are the smallest bodies. Most of them are probably like a grain of sand. Some of them are extremely large. Ceres is named as a named asteroid. Is about 1,000 kilometers in diameter. It's about 600 miles in diameter. So very, very huge object that is an asteroid. To get hit by that would probably hurt really bad. The orbits are kind of crazy sometimes as different things are pulling them out of where they're moving. Remember, if they're moving, it takes a gravity field in order to change their movement. So depending on what area of space they are, and a planet like Jupiter could certainly distort the orbit of one of these asteroids. Other planets can too, and you have lots of evidence that the moon has been struck with asteroids, and lots of asteroid collision sites have been found on Earth as well. So what are they and where are they? Not 100% sure. Most of them lie in an asteroid belt between Mars and Jupiter. So if you were to go from the Earth to Mars, that is a very small distance of the solar system, just a small percentage of the solar system. Then there is an enormous distance between Mars and Jupiter, humongous different distance. And there is no planet there, but there are trillions of these rocks that all kind of go in a swarm around the sun at a certain location. Back in the days of Kepler, we heard of Kepler. Kepler, according to Kepler's laws, we looked at his 3 laws. One of his laws suggested that there was a planet that located between Mars and Jupiter. And people looked for it for a long time because his book said, according to the math, there should be a planet at this location. But no one could ever find it. It was only later that they realized that all of these rocks, huge swarm of rocks, were existing at that location, exactly where Kepler had suggested that they would be. Don't know what the consensus theory is at the moment. Some believe that it used to be a planet that was exploded. Maybe the Death Star came and got it. Don't know about that. But if you were to add all the rocks together, you end up with a very, very small planet, way smaller than Earth, maybe 1% of Earth. So it's not enough to be a planet. It would be very small if it were, but all the rocks together have the same gravity that a planet would have, only it's kind of spread out in a big elliptical orbit. A lot of these asteroids are just weird shapes, pieces of rock, pieces of metal, different things involved in them, and they just lie at extreme distances of a big wide space between the Earth's orbit, Mars orbit and Jupiter's orbit. And all of this together is called the asteroid belt. We're going to see that there's a second asteroid belt called the Kuiper Belt beyond the orbit of Pluto, and possibly containing lots of planetoids. There's been at least 2 found, Pluto, and then a second one. So there was a 10th planet for just a very short while until they realized that the more planets they were going to find were going to be tiny, 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 and that's why they decided to actually call them planetesimals rather than planets. We'll look at the Kuiper Belt in a few minutes. The next fascinating group of small solar system objects are the comets. And the comets, a lot of people will call them dirty snowballs because they're made up, there's ice, there's frozen gases, so there would be frozen methane, there's frozen ammonia. and possibly having a core of some kind of metals or rocks on the very inside of it. And where they're from, not a lot of sure. A lot of people think they're from the Kuiper Belt or Kuiper Belt, which is on the other side of Pluto's orbit. They have their own orbit around the sun, like a planet would. Some of these are very, very small. As they come closer to the sun, they're going to vaporize much of it, and you're going to have a huge glowing mass that's going to come. Some of these called a coma, and this glowing head can sometimes be as big as the sun itself, huge, or big as Jupiter. So they could be big depending on how big the snowball is. The Kuiper Belt is beyond Pluto's orbit, is most likely the home of these comets, and as gravity is pulling them, they can start in towards the sun. There have been comets that have struck planets or struck Jupiter because Jupiter has so much gravity, but mainly it's heading towards the sun and then is basically slung away from the sun by the sun's gravity. So many of these will have a period short enough to be measured, and the most famous of that is Halley's Comet. And Halley's Comet comes every 76 years, and that has been recorded. The Chinese astronomers have recorded every one of the 29 passings of Halley's Comet since like 250 BC. So people will know they know it, and they know how long it will be. So even hundreds of years ago, people knew enough about this one to realize that the same comet was coming every 76 years from these various records, and an English astronomer put his name to it. So Halley's Comet came in 1910 or something like that, and then 1986. I remember seeing Halley's Comet. It was pretty awesome because people were like, it'll only happen once in your lifetime. There's actually been a couple of really cool comets. You can see it during the daytime because there's so much reflection of these gases from the sun that it's almost like when you see a jet flying across the sky. You can see it, the big white billows, and you can see that. You can see that often. I know I've seen a couple of these comets during the day, and especially at night. You can see them, and they seem to be really, really slow because it's coming through the entire solar system, and so it's like you can see it night after night, kind of in the same place, heading towards the sun, and then it turns and then leaves in another route. It's pretty amazing. I like them a lot. The top picture of the comet shows you that the tail is going to change. The tail is always opposite the sun. So the tail is not like when you see a cartoon of a car and the speed lines always go away from the motion. As it's coming towards the sun, it's the sun and the sun's solar wind that's actually vaporizing the material and also ionizing some of this material, and what you're seeing is shining always away from the sun. So many comets actually have two tails. The big fattish tail is going to be the dust and the ice that's vaporizing, mostly the stuff that's coming off of it that's leaving a trail behind the comet. And then you have a thin, very bright tail that's usually ionized gas, and it's always going to be exactly opposite the sun. So the skinny tail is always opposite the sun, and then the dust tail usually is lagging in one direction or another. You can see on the right this coma, which is, you have the inside part, which you can see is bright yellow, and then you have this huge kind of gas cloud around it called the coma, and the coma can be enormous. You can also see that it's possible that many of these have a rocky center or an iron core to the inside of this snowball. When a comet comes through, it's going to leave lots of debris floating in the Earth. Okay, so if the Earth is moving around the sun, the Earth is actually often encountering these small pieces of material. So whether they're rocks, whether they're sand, whether they're made of different things, the the Earth's gravity field can catch these rocks, if you want to think of them, or these iron pieces, and bring them in. So once they start into the atmosphere, they're falling just like anything would fall in the atmosphere. And as it falls, it's encountering lots of friction with the atmosphere and getting faster and faster, and they heat up. So a meteor is what you call a falling star. So it's whenever this material often left over by comets will fall into the atmosphere, and you can see meteors every night of the year. Every night there's a clear night, you will see some falling stars because there's lots of debris in space that could be caught by a planet as it's going around in that area. Because there's lots of material left over by comets in certain places, you end up with a shower. And and in very specific times of the year because it's in certain places in the path. So imagine walking around the football field over and over again, and there's a mud hole at one place. Every time you come to that place, you're going to have to walk through the mud. It's the same really idea. You've got leftover material in a certain place in space, and it's just kind of hanging out there. And every time the Earth comes around the sun in that area of space, it's going to encounter the same stuff. And so a meteor shower, there's meteor showers in various months named after the constellations that they seem to come out of it. So you have the Perseid meteor shower, the Draconid meteor shower, the Leonid meteor shower, all coming from Leo the lion and Draco the dragon, and all of these places, Perseus. So seemingly to come out of that area, it's the star constellation that you're looking at as you're approaching, as the Earth is going into that field. So they are made of different things. You can have some metal cores, so some iron and some nickel. You can have some rocky ones, and you can even have very rare ones that have some organic material, some like RNA or even amino acids that they can find that some have linked to all kinds of different theories. The most famous meteor site in America is in Arizona called Meteor Crater. And it's about 3/4 of a mile across, about 500 feet deep, and thousands of pieces of iron has been found in that area that struck it. It could have been ages ago. It's struck into various layers of the ground. Impact. There's all kinds of ejecta that comes up from a crater impact, and then a long time ago you would even have the rays of the dust as it fell from that explosion. You can see the same even with a bomb crater. A bomb goes off and leaves a crater, and you have the ejecta that comes up from it. So this is in, I think, Winslow, Arizona. In any case, it's a big tourist attraction. I'd like to go. I've never been to Arizona. We're now going to look at the dwarf planets. So Pluto is now considered a dwarf planet or a planetesimal rather than a planet. You actually have a few beyond that were one time thought of as the 10th planet. Pluto is the 9th planet, 10th planet, and then they realized that these planets are tiny. So it's funny, it is a planet because it's going to have a moon of its own. Pluto has a moon called Charon, but compared to our moon, it's a dinky little tiny town-sized moon. It is very, very small as a planet, almost like Little Prince standing on his little planet to where he could just walk around it in a minute. It's kind of the same thing. So Pluto is 1/5 of the diameter of the Earth, about half of Mercury's diameter, so really, really small. And then the 10th planet, which was named after one of the Eskimo goddesses, can't remember that name. The 10th planet also even smaller than Pluto. Beyond that orbit, you have what's known as the Kuiper Belt. And the Kuiper Belt is another asteroid belt, mostly kind of comety asteroids, so icy, rocky asteroids. And so it is thought that that's where the comets originate, that they're floating around there and they'll be tugged by gravity and eventually tugged enough to start a path towards the sun, and then it comes in towards the sun and then slung back out by the sun's gravity, and then it hangs out there enough to come back in. So you've got lots of things in the solar system that are still not well understood. And more study, more traveling. We need Star Trek. So hope you enjoyed that.